Hi girls, welcome to lesson 3 of the chemistry of the atmosphere topic. Today we're going to be looking at atmospheric pollutants. So your starter today is just a nice little summary of endothermic and exothermic reactions. You could draw up this table and answer it. So just pause your video. Okay, so here's the answers. So endothermic reaction. Our reaction profile looks like this. You'll see that our reactants have less energy than our products. In an endothermic reaction, the temperature of the surroundings will decrease. You'll get a net absorption of energy. It'll be a positive enthalpy change. Your reactants have less energy than your products. You release less energy when you make bonds than what you needed to break the bonds, which is why our activation energy is so high. Examples: thermal decomposition, reaction of citric acid and sodium hydrogen carbonate. Products which use them: sports injury packs. Exothermic reactions are the opposite. Our reactants are much higher than our products. The temperature surroundings increases. Thermal energy, you got a net release of energy. Enthalpy change is negative. Reactants have more energy than the products. We release more energy when we make bonds than what we needed to break bonds. And that's why our activation energy is much smaller. Products which use them are examples: combustion, oxidation reactions, neutralization, and products which use them: self-heating cans and hand warmers. So that is a really nice little summary of that topic. So combustion reactions. Combustion reactions we use to get energy from fuel. So fuel is a good energy source because when fuels are oxidized, they release lots of energy. So we're talking about oxidized. So here we are reacting with oxygen. Reacting with oxygen. Okay. So when fuels are completely oxidized, they will produce carbon dioxide and water vapor. And combustion is an exothermic reaction because we get an overall release of thermal energy when combustion reactions happen. Okay. So here's 3 fuels: methane, propane, and ethane. And what I want you to do is balance these reactions for complete combustion. So you will notice that your products are always carbon dioxide and water. So methane and propane aren't too hard, but ethane is a little bit trickier. So just pause your video. Okay, the trick with balancing combustion reactions is you always leave the oxygen to the end. So okay. So the first thing that we notice is that there are 4 hydrogens and only 2 here. So the first thing I will do is put a 2 to make that equal. Now I've got 2 and 4 oxygens. So I need to put a 2 out the front to get 4 oxygen. Now I've got 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, and then 2 plus 2 is also 4 oxygens, so that is correct. Propane. Okay, so remember, we always leave the oxygens until last. We've got a few things to sort out here. So the first thing we need to sort out is the carbons. There's 3 here and only 1 here, so I can put a 3 in front of there. And we've also got 8 hydrogens here, but only 2 here. So I need to put a 4 in front of there. Now, because we left the oxygens to last, it's quite easy to work out what we need to put in front of the O2s. So 3 times 2 is 6, plus 4 times 1 is 4, so that is 10 oxygens. Okay, that's not a word, sorry about the pen. So that means I need 5 times 2. So ethane is a little bit harder because we're going to have to do some trial and error. So I always leave oxygen to the last. So let's have a look here. So the first thing I notice here is that I've got 2 carbons. So I'll put a 2 in front. And I've got 6 hydrogens. So I put a 3 in front. Now I've got 4 oxygens plus 3 oxygens, so 7. 7 is not a very nice number, okay? So what we'll do is we will try a different approach. So if we put a 2, if we put a 2 in front of here, we now have 4 carbons. And we've got 12 hydrogens. So I put a 6 in front of here. Now this is a lot nicer because we now have even numbers. So we've got 8 oxygens here plus 6 oxygens here, which is 14. And that means I need 7 here, okay? So hopefully you worked that out. Can you please just take a couple of minutes, not even, it should take you about 90 seconds just to answer those test yourself questions. So just pause your video when you're ready. Okay. What are the products of complete combustion? It is always carbon dioxide and water. What gas is needed as a reactant? If it's a combustion reaction, we need oxygen. And the reaction is exothermic because we have a transfer of thermal energy to the surroundings, or a net release of thermal energy to the surroundings. Okay, so we will move on. Okay. I'll just clear all those drawings. So, unfortunately, in engines and in factories, complete combustion doesn't always occur. So when the oxygen, when it's not completely oxidized, the fuel, we not only get carbon dioxide and water, but we also get carbon particulates, which are called soot, and we also get carbon monoxide. Okay. Now, carbon monoxide is really dangerous because you cannot see it, taste it, or smell it, but it can kill you really quickly with no warning. And that's because it binds to hemoglobin better than oxygen. So not enough oxygen gets to your cells. If your cells don't have enough oxygen, they won't respire, not have enough energy to do the processes, so the cells start to die. And the common signs are headaches, nausea, dizziness, breathlessness, loss of consciousness, collapse, and even death. Now, carbon particulates are called soot. They do a few things. So they irritate your respiratory system, and they also cause global dimming. So if you look out on the London cityscape, some days are really smoggy, and that's because it's difficult for the sunlight to get to the surface. because it's reflected by the carbon particulates. And that's what we call global dimming, but we will talk about that later in the presentation. So lots of things happen inside engines or factories that cause atmospheric pollutants. So our fossil fuel goes in, petrol, diesel, or gases. This reacts with oxygen. It's an exothermic reaction, so the temperature gets very, very hot. And also inside engines, we've got things that cause a spark, and they provide the activation energy for the reaction to happen. So nitrogen gas in the air reacts with oxygen gas in the air to produce nitrous oxide compounds. All right, nitrous oxide compounds are an atmospheric pollutant, and we'll talk about that later in the presentation. We get complete combustion, so oxygen and carbon dioxide, sorry, that should say water. Water and carbon dioxide are released. You sometimes also get incomplete combustion, so you get water, carbon dioxide, carbon particulates, and carbon monoxide. Remember, carbon dioxide is also bad because it's a greenhouse gas, so it absorbs heat. So fossil fuels sometimes contain sulfur compounds. When the fuel reacts, those sulfur compounds will react with oxygen and form sulfur dioxide, which is also a pollutant. So from running cars and factories, that causes lots of pollution in the atmosphere. Okay, so here is a nice little summary of the source and the problems with the different atmospheric pollutants. So methane we get from livestock farming through digestive processes or flatulence or farts, if you will. Problem is greenhouse gases trap heat in the atmosphere, so that contributes to global warming. Carbon dioxide we get from burning fossil fuels through complete combustion and incomplete combustion. Greenhouse gases trap heat in the atmosphere. Sulfur dioxide, combustion of fossil fuels when sulfur particles react with oxygen. This causes acid rain, and it can also affect your respiratory system. Oxides of nitrogen, they react with oxygen inside engines to form, and that causes acid rain. Carbon monoxide, remember it's toxic, but it's colorless and odorless, so it's hard to detect. You get that from burning fossil fuels with incomplete combustion. And the problem is that it binds to hemoglobin instead of oxygen. So the lack of oxygen in your cells can lead to fainting, unconsciousness, coma, or death. Carbon particulates or soot, you get them from burning fossil fuels, which gives you incomplete combustion. It blocks out the sunlight, causing global dimming, and also inhaling those particles will damage your lungs. Okay. So we're going to talk a little bit about acid rain. Now, the good thing about learning about acid rain is that it's in the chemistry. Well, apart from you need to know about pollution, but also in terms of your GCSE exams, it's in both the biology and chemistry specification. So sulfur dioxide and nitrogen dioxide. It can also be other nitrous oxides. So you could have, say, NO or NO2, etc. They are released from cars and factories. Now, we talked about on the engine slide the specific way that happens, and you do need to know that, okay? Then we've got water vapor in the atmosphere. The sulfur dioxide reacts with water to form sulfuric acid, and our nitrous oxides react with water to form nitric acid. Now, the sulfuric and nitric acid fall to the ground as rain or snow when precipitation happens. And this is a problem because it kills aquatic organisms. It strips the leaves off trees, which causes them to die. We'll just add a little, just add something there. Causes them to die because they cannot photosynthesize. It also affects respiratory system of animals, so breathing in acid rain is not good. A non-living effect is that the acid reacts with calcium carbonate, so it destroys any limestone buildings. So if I were you, I would draw a little diagram and I would label each step. Okay, you could add the extra things about how these occur specifically in engines because that is really important. Okay, so here is some example of some statues which have been damaged by acid rain. Okay. Take a couple of minutes to do these test yourself questions. Pause your video. Okay, so give 2 reasons why carbon particulates are dangerous. They cause global dimming, so you get less sunlight reaching the surface of the Earth. And also carbon particulates can damage your respiratory system. Carbon monoxide is dangerous because it binds to hemoglobin instead of oxygen. And this means your cells don't receive enough oxygen, which can lead to cell death, fainting, coma, and death. Carbon monoxide is difficult to detect because it is odorless and colorless. The 2 gases which contribute to acid rain, we've got the nitrous oxides and sulfur dioxide. Why does acid rain damage buildings? It reacts with calcium carbonate, which is part of limestone. All right. Okay. And we might just do that reaction here. So remember, metal carbonate plus acid gives you salt plus water plus carbon dioxide. So if we have calcium carbonate, which is limestone, and that reacts with sulfuric acid, we get calcium sulfate plus water plus carbon dioxide. Okay. So why don't you see if you can do the reaction of calcium carbonate with nitric acid? So just pause your video, write that out. Okay, so if we had nitric acid, calcium carbonate plus nitric acid gives us calcium nitrate plus water plus carbon dioxide. Either way, the calcium carbonate, which is the limestone, is destroyed. Okay. So can you summarize the steps here? Test yourself, see what you can remember without looking. Pause your video. Okay. Okay, so outline the steps involved in the formation of acid rain. Sulfur dioxide or nitrogen oxides released from cars and factories into atmosphere react with water vapor, form sulfuric acid or nitric acid. The equations are there, and it falls to earth as rain or snow. Effects of acid rain on living things: kills aquatic organisms, strips leaves off trees, so stunts growth by preventing photosynthesis, irritates respiratory systems of animals. Global dimming, we talked about that a bit. So particulates in the air block the entry of sunlight to the surface. So the light gets reflected off the particles, so it doesn't reach the surface. So that has consequences such as maybe not getting enough sunlight, or it just being dark or smoggy, etc. Okay, there's two little exam questions here. Have a go at them. This one here is worth 4 marks. 4 marks. Okay. So the first one, copper can be extracted by smelting copper-rich ores in a furnace. Explain why there would be an environmental problem if sulfur dioxide gas escaped. So the main point here is you needed to say that sulfur dioxide forms sulfuric acid, which can fall as acid rain. And this could either affect respiratory systems, animals, kill aquatic organisms, strip leaves off trees, so reduces photosynthesis and stunts growth. So you just needed one of those points. But you needed to make sure you said that sulfur dioxide reacts with water to form sulfuric acid, and that falls to the ground as acid rain. So copper metal is used in electrical appliances. Describe the bonding in a metal and explain why it conducts electricity. So this is from C2 biospec. So it's a lattice of positive ions surrounded by delocalized outer shell electrons. The bond is held together because of electrostatic attraction between positive ions and the electrons. And it conducts electricity because electrons can move through the metal and carry charge. The end.